Now for the other side of the coin, we talk about the compound and inequalities. And statements are more restrictive. They usually have fewer numbers that are shaded overall. Even the way that we graph is going to be a little bit different. When we were looking at the ORs, we started immediately on the number line. We shaded without regard for the previous statement. For AND statements, it's quite the opposite. You have to look at the totality of your statements, and you're really looking for the overlap between the two statements. An example of what I'm referring to. Again, I had to solve two inequalities at some point in time, and I get down to my set building notation, my solution sets. Maybe I have the set penguin such that penguin is greater than or equal to -3, and the set penguin such that penguin is less than 11. I'll draw my number line, and you'll see the difference on how I come up with my solution here. The first step, I will locate the -3 like we did before. That doesn't really change. However, when I notice that this is going to be a closed circle, I will graph above my number line. As I graph above my number line, notice that I made that a colored in circle, and I'll shoot this off to the right as it's telling me to do. Next, I need to find the 11. 11 would be found to the right of 0. That indicates, when it's a strict less than, that I would have an open circle, and this one tells me to shade off to the left. Now I'm looking for that opportunity to have overlap where both of those statements exist at the same time. So I'll start to the far left. As I'm at the far left, I do not have both statements that exist. I only have the bottom statement, so no shading can occur here. When I get to the -3, I do notice that the point exists here and there's shading here, so it's a double shading, which means that this would be a closed-in point. All the way between -3 and 11, both of the shadings exist, so I'll do my shading on the number line. When I get to 11, because this is a hole, a ghost point, it doesn't really exist. Since it does not exist, I'll leave that as an open circle. And as I travel beyond the 11, I notice that I only have one of the shadings. When you look at a compound and inequality, the only thing that could be shaded, or the only place that can be shaded, is where both of your statements exist concurrently, where they both exist at the same time. So when we look at this, we're saying the significance of the shaded region, if you choose a number in here like 2, because 2 is a shaded number, 2 would solve both the first statement, 2 is bigger than or equal to -3, and it solves the second statement, 2 is less than 11. You have to allow for both of these characteristics to exist at the same time, and those are the only numbers that are allowed to be shaded. I repeat, how we do this. You'll graph the first one above the number line, the second beneath the number line, and you're looking for that overlap. You must learn that as a technique for solving AND inequalities, and compound inequalities. There's our first example for the AND compound inequality.